Welcome to today's Explainer. We're about to take a seriously fascinating look under the hood of global gaming networks. Every single second you're in a multiplayer match, your machine is frantically processing thousands of data packets just to keep you alive. But what if you want to mask where those packets are actually coming from? Or what if a developer needs to stress test a massive server across the globe right before a big launch? Well, today we're stripping away all the marketing fluff. We're going to understand the true network architecture behind modern gaming connectivity. We're breaking down exactly what gaming proxies are, how they function, and why they are an absolute essential tool for everyone from QA testers to esports professionals.
Okay, let's dive into this. Think of this agenda as our main menu to really level up our understanding today. We'll be hitting 1. What is a gaming proxy? 2. Core use cases for gaming. 3. The ping and latency myth. 4. Gaming proxies versus VPNs. 5. Choosing your proxy type. And finally, 6. Why SOC 5 is preferred.
Section 1. What is a gaming proxy?
To really grasp the advanced tactics here, we need a clear, objective foundation of what is actually happening behind the scenes of your game connection. When you play an online game normally, your computer sends data directly from your home internet connection straight to the game's server. Your IP address, basically your digital home address, is completely visible to them. A gaming proxy changes that entire architecture by acting as an intermediary server. Think of it like a digital intermediary outpost. Instead of your data traveling directly to the game server, it first travels to this proxy outpost. The outpost then forwards your data using its own IP address. When the game server sends data back, it goes to the outpost, which securely hands it back to you. The game server literally only ever sees the outpost, completely masking your true home connection.
Section 2. Core use cases for gaming.
So, why do actual gamers, QA testers, and software developers rely on these intermediary outposts every single day? Well, the applications are incredibly diverse. First, consider accessing region-locked servers. Imagine a highly anticipated Korean MMO beta drops, but it's totally locked to local players. A proxy allows a user to route their connection through an IP address actually located in South Korea, unlocking access. But it's not just for playing, it's for protection too. There are notorious stories of esports streamers having massive tournament runs completely ruined by targeted DDoS attacks. Streamers use proxies to separate and hide their residential IPs, securing their privacy and keeping their connection alive. On the development side, imagine you're building an MMORPG. Developers need to simulate how players globally will experience the matchmaking system, right? Proxies allow a QA team sitting in one single office to test the game from virtually anywhere in the world. They can verify local pricing, regional events, and seamlessly manage multiple testing accounts.
Section 3. The ping and latency myth.
Okay, we need to address the elephant in the room here. This is perhaps the most common misconception in the entire gaming community when it comes to network technology. So let me ask you the question directly. Do gaming proxies reduce ping?
The reality is, not necessarily. We really need to bust this snake oil myth right here and now. A proxy does not magically fix latency out of thin air. In fact, by the sheer laws of physics, adding an extra intermediary server between you and the game can sometimes actually increase your ping simply because your data is taking a longer physical trip.
So, the crucial point is that a proxy is not some magic speed button. It's a routing tool. It might improve your connection only under very specific circumstances. For instance, sometimes your home internet service provider uses terrible, incredibly inefficient routing to reach a game server, bouncing your data all over the place. In that specific scenario, routing your traffic through a high-quality proxy can actually create a much more direct, consistent network path. It's kind of like taking a well-paved direct toll road instead of a winding, congested dirt path. But make no mistake, the primary benefits here remain privacy, flexibility, and testing, not guaranteed lower latency.
Section 4. Gaming proxies versus VPNs.
And this brilliantly illustrates the inevitable comparison. If we're talking about changing IP addresses and routing traffic, we have to talk about VPNs. Both of these tools change your IP address, but they do it in fundamentally different ways. A VPN is a heavy-duty tool. It encrypts every single piece of data leaving your device. That heavy-duty encryption, it can sometimes add 20 to 30% more latency overhead. In a competitive, fast-paced shooter, that is literally a death sentence. A gaming proxy, on the other hand, skips that heavy encryption. It's lightweight. Plus, a proxy can be configured to route only specific applications, like just your game client, while letting your Spotify or Discord run normally on your home network. This low overhead and application-specific targeting is exactly why developers and serious gamers prefer proxies over standard VPNs.
Section 5. Choosing your proxy type.
Choosing your proxy type is actually a lot like choosing your character class in an RPG. You have to match the exact right technical specifications to your specific gaming or testing needs. The two most common classes are datacenter and residential proxies. Datacenter proxies are generated in massive server farms. They offer raw, exceptional speed and are highly scalable. If you are a game dev who needs to run thousands of automated bots to stress test a new server, this is 100% your choice. Conversely, residential proxies are IP addresses officially assigned to real households by standard internet providers. Because they look exactly like a normal user just sitting in their living room, they are highly trusted by game servers. If you need authentic access to a regional marketplace or a closed beta test without instantly getting flagged as a bot, residential is absolutely the way to go.
But what if you kind of need both? Enter ISP proxies. These are essentially the best of both worlds, a hybrid class. They give you the blazing speed and stability of a data center, but the IP addresses are officially registered to internet service providers, giving them that trusted residential status. Because these IPs are static, meaning they don't change constantly, they are incredibly reliable for long, competitive gaming sessions or managing a dedicated developer account over a long period of time.
And finally, we have mobile proxies. These are highly specialized. Instead of routing through a server or a home router, your connection is routed completely through real 3G, 4G, and 5G mobile networks. Now, why does this matter for gaming? Well, because mobile game developers need authentic tools to test how their iOS or Android apps actually perform on real cell towers, or to verify carrier-specific features globally. It's all about perfectly simulating the exact environment of the end user.
Let's move to and see how this builds into Section 6, why SOCKS 5 is preferred.
When it comes to the absolute gold standard in gaming network protocols, one stands head and shoulders above the rest, and that is SOCKS 5. Standard proxies often use HTTP, which is great if you're just browsing web pages, but it's pretty terrible for the complex data packets required by real-time games. SOCKS 5 operates at a much lower network level. It works quietly and efficiently right under the hood, stripping away the limitations of standard web traffic to ensure game clients run as smoothly as humanly possible.
Breaking down these final technical benefits, SOCKS 5 offers vast compatibility with modern gaming clients. But the real game changer? It's its support for both TCP and UDP traffic. Most fast-paced multiplayer shooters and fighting games rely heavily on UDP traffic because it prioritizes pure speed over data confirmation. HTTP proxies just cannot handle UDP traffic. SOCKS 5 handles it effortlessly, with significantly lower protocol overhead. It basically gives developers and players the flexible, lightning-fast routing required for real-time action.
Now, what's really interesting about this slide is the fascinating question it raises for the future. We've seen how these tools allow developers to build way better games and players to protect their privacy and optimize their routing. But as the industry pushes further and further into cloud-based gaming, where your physical distance from a server dictates your entire experience, will knowing how to customize your network routing become a mandatory skill? Will using these intermediary outposts become the standard for every single competitive player out there? It's a pretty provocative thought to leave you with. Thank you so much for joining me on this explainer today, and keep learning.